All right, good morning, everybody. Today we have an exciting new topic, JSON files. It's another way to store data, a lot like CSV files. But before we get started, I just want to do a little bit of review to get us started. So first up, we're going to go over to the web page and download some files to follow along during this lecture. All right, so I just jumped over to our web page. We are right here on October 16th, JSON Day. Please notice, go ahead and read Swigart Chapter 14 about JSON files. The PDF slides you'll need are right here. We will be copying and pasting some things into the files we're using today directly from the slides. Just like when we talked about CSVs, these are just little functions that will read JSON files. All right, we've got worksheets here. We're going to do one of the problems from the PDF worksheet to get started. Two of the problems from the PDF worksheet appeared on a really old version of the class. We've included the old worksheet too because it's got some great problems. So we've got 5 problems on the old worksheet. We moved 2 of them over to the new one and added that third problem. The third problem is the one I'm going to be doing first up in class. All right, in the code directory, I've already got that open right here. If you're watching my lecture, I've got a template right here, currently blank because I'm going to build it as I go and write the lecture. So if you're here early, it's blank. When I'm all done, I'm going to have a lecture right here. This will be all of the stuff I do during class. Basically, I do the stuff during class, then I delete it, so there's a template for you guys to fill in. You will also need this Looney List picture. Here, let me show you the worksheet. Has these 2 problems, and then we've added the third one. This is the Looney List picture. This is the one we're going to do, but I'm going to do it in Jupyter Notebook. So I've made a copy of the picture, and in order for that to appear in your Jupyter Notebook, you'll need to copy all of these files into the same directory. And the rest of these we're going to be developing during class, so you can see the results of the versions we've created. You can go back to them later, or if you just follow along, you can create them yourself as we go through the lecture. All right, let's get started by taking a look at that worksheet problem 3. I've copied the code over here into Jupyter Notebook. I like the way it color codes it. It gives you guys the opportunity to have cells and actually do this yourself right here without having to print it out. If you want to, definitely go print out the worksheet. You can do this with pen and paper. I prefer this, especially for lecture demos. All right, so this first up is a crazy data structure. This is the Python tutor picture. Please never write code that ends up looking like this. It's crazy, it's confusing, but that's kind of the point, is we're going to be tracing through some things that just look silly and making sure that we understand what's really going on. So it's good practice. Don't ever do this in real life. It's confusing. All right, so let's take a look at what we've got here. First up, we're creating a dictionary. That dictionary is named Webster, which is a little inside joke if you're familiar with dictionaries and old like me. All right, inside the dictionary, we've got 3 key value pairs. Keys are A, B, and Z. All right, the value for key A is a list. I can see the square bracket right there. It's got a bunch of words in it that all begin with A. Then the key B is paired with the value here is another list. I see the brackets there in green, bike and debug, both present in that list. And the key Z has a dictionary inside of it. So we can do some weird stuff with dictionaries. We've got lists and dictionaries as values. This particular dictionary has 2 key value pairs. Name is paired with the value zebra, the key kind paired with the value mammal. So some information about zebras that you might find important. Next up, we're creating a list. This is named Looney List. It has 3 values in it, integer 8, integer 9, and that dictionary we just created up here. Let's just peek down here at the picture. So I've got in the global flame, I've created Webster, which is this dictionary right here with keys A, B, and Z. Then we have Looney List, which is this list right here with 8, 9, and then the dictionary Webster up there. All right, that's how far we are right now. Then Looney List is going to append another copy of Looney List. So what we see here is that the very last entry of appended something here is now pointed to the corner. So it's got a copy of itself inside of itself, which is a pretty good reason for the name. After that, we are going to take Webster, add a new entry by using these square brackets, and we're going to put Looney List in the dictionary. So now we have this capital L key that is also pointing to Looney List. So it's getting a little crazy. Then we're going to define a function We call the function. So let's go back up here. We are giving it loony list. That's getting put into the parameter everything. So here in the foo frame, we have a parameter everything, and that's given loony list, which is right here, this data structure, which contains Webster, contains itself. And then we're creating a new data structure, final letter, which is loony list, or everything, but just a part of it, 2 and Z. So final letter here is going to be just a piece of the everything, or the loony list. All right, so now what we want to do is go down here. On the worksheet, there are like 10 different questions. It's asking if we print out and replace those question marks with loony list 1, what's it going to print out? If we go and take those question marks and replace them with Webster of A of -1, what is it going to print out? All right, so if you just run some of these cells, they will just work, but that's not how I want you guys to use this worksheet. If you like do kernel restart run all, it'll fill them all in and you won't get the practice. Instead, what I want you to do is take loony list 1, and maybe just let's go through this as an example. I'm going to find loony list over here. It's available in the global frame, and I'm going to trace this arrow. So this is loony list right here. When I point to the corner of something with my mouse pointer, I'm talking about the data structure. Okay, now I'm going to grab element 1 here. So right here, this is element 0, element 9. So now I've got my, element 0, element 1 is a 9. I've got the mouse pointer inside the box. It's now pointing to the 9. So loony list of 1 should give me a 9 when I run this cell. And indeed, it does. All right, that's how I want you guys to use this. I want you to not just run the cell. I want you to trace through. I want you to make a prediction, put it down in there. Maybe I'll do one more. Webster A -1. So I'm going to go up. Here's Webster. Let me just use the picture. I've got my data structure Webster. It's in the global frame. I'm going to follow the arrow over here. When I'm pointing to the corner, I'm thinking about the entire data structure. I'm accessing the key. I think it was an A. What am I doing? Yep, I'm accessing the key A. So I'm going to jump in here and follow this arrow to this set right here. And then I was indexing and getting element -1. So a -1 in a list is just that very last thing right here. Looks like we're looking at the text Ada. And note, I didn't show any quotes on strings. So all these text are just strings. So I'm going to predict that this is going to give me Ada. All right, now that I've got my prediction, I've written something down, I've committed, I can do Control-Enter, and it'll actually look it up and see what this cell gives me. All right, what I'm going to do right now is just give you guys about 3 minutes to go through some of these. If it's the live stream, I'm going to just pause, and we'll come back. We can do some of these after class during the Q&A session if you guys have any questions, if something doesn't come out the way you think it should. The only one of these that I think won't run directly is the final letter one, because final letter is only, final letter and everything. They're only available inside the function, and as soon as that function terminates, they won't just run. So the global runs, loony list and Webster will all just run on their own. But if you want to talk about any of these, we can go ahead and do that. All right. If you're at home just watching the video, push pause. Give these a try. Just do this now. If you have questions, bring them to Piazza. If you're watching the live stream, I'm going to pause the video play and give you guys a chance to just try some of these. All right, do that now. All right, welcome back. I thought I'd just pull out 2 of these and talk a little bit about more of them. First, this final letter one. I'm going to make a copy of this, and I'm going to go ahead and just put it in. So if you're curious about how to make the final letter one work, going right here. There we go, final letter. Now when I run this, let's just trace through this. Final letter is available inside of the function, so that's why I needed to copy it. When I trace final letter, I'm over here at this data structure. I'm going to look up the name, so it is a dictionary, and I can see I've got the key value pairs here. Name is going to be this text right here, zebra. And then when I look at the -1, so far, this much of it, final letter all the way through name, is going to give me a string. Okay, so when Python looks at this, it's just going to be evaluating left to right, going through all of these brackets, tracing through all of the arrows. -1 is going to be the very last letter of the string, the A. So if I run this cell now, instead of printing out question marks, it's going to give me the A. All right, I'll go ahead and put that back. because I'm going to use the same thing as my template in a little bit. The other one I want to take a look at is this crazy thing. Looney list 3 minus 1, 3 minus 1, 3 minus 1, 3 minus 1, 0. Okay, so if I go up here, Looney list is available in global scope, so that if I just run that cell, it will work. But the idea is I'm going to follow my arrow over to Looney list. So here 0, 1, 2, 3 is this one right here at the end, which contains a copy of Looney list. So I'm going to trace that arrow back over here to the beginning. Then element minus 1 is the very last one. That's this one right here again. Trace it back. 3 is this one. Minus 1 is this one. 3 is this one. Minus 1 is this one. So we just keep looping through deeper and deeper and deeper, but it's the same data structure the whole time. Eventually that last item was 0, unless I'm mistaken. So this should give me an 8 when I run this cell. So, yep, last one was 0. When I run this cell, I'm going to get an 8. So I hope that kind of makes sense. If tracing through any of these, like indexing into a dictionary, or indexing into a dictionary, or indexing into a list, I think I said that wrong, or any of these nested lists inside of dictionaries, inside of lists, inside of lists, inside of dictionaries, if any of this is confusing, you know, let's face it, this has a lot going on. There are more problems on the Word doc worksheet and more problems on the PDF version of the worksheet. So definitely go check those out. All right, next I'm going to jump back over to the PowerPoint slides. So in part 2 of the lecture, I want to start talking about different file formats and data structures that seem to work well with them. So we've already talked about lists of lists and how they're closely related to CSV files. So here I've got a list of lists with my header row, name, X and Y. I've got some players and their positions on the board, X and Y positions. So I've got Alice and Bob playing. If I put this into a CSV file, this is what it's going to look like. I'm just going to have each of the pieces of text separated by commas. Each row is going to be their own list in the list of lists when we read this in. All right, this works great for tabular kind of data here. In fact, it's asking data we would want to use in lists of lists, tables, things like spreadsheets. But not all of the data we're going to be using in Python are nice, neat tables. Now let's take a look at this, for example. Here I've got a dictionary of dictionaries. So it's got, this dictionary has 2 entries. Alice and Bob are the keys, and each of them have their own dictionary as an entry or a value. Inside Alice's dictionary, she's got 2 keys and 2 key value pairs. Age, she's 40, and scores, it looks like she's played the game 3 times and scored 10, 20, and 19 points. So this is actually a list in a dictionary in a dictionary. All right, very similar for Bob. He's got a dictionary as his value. Age is 45, same age as me. And he's played the game 4 times, 15, 23, 17, 15. Of course, he's older. Maybe he's had more time to play more. But here's the idea. If I wanted to put this data structure into a CSV file, how do I do that? It looks like I could use maybe 1 row for Alice, 1 row for Bob, and then just like here, the values, the first one could be their age, the 40. For my header, I could have name, age, and then I'm not really sure. Alice's rows only could have 3 more pieces of data, 10, 20, 19. Sure, I could put those in the row. Bob's data is going to have 4 more items. It doesn't make a really great list of lists. So what do? Put in a bunch of blank, empty strings for the rest of the scores for Alice. This is a challenge. And to the rescue, we have JSON files. So here is the equivalent JSON data formatted file for this dictionary. All right, I want you to point out a couple of things here. First, there are some strong similarities between JSON file formats and dictionaries. All right, first, we are going to use curly braces to indicate a dictionary in a JSON file. Second, we're going to use colons to separate key value pairs. Third, we're going to use brackets for lists. And a JSON file doesn't need to be a dictionary. It can also just be a list, or just a floating point number, or just an integer, or just a string. But in this case, I'm using dictionary as my example. And dictionaries can contain lists. All right, let's see. Strings are always going to be in quotes, just like in Python. And integers will look like integers. Floating point numbers look like floating point numbers. Okay, so just a little bit more. JSON stands for JavaScript Object Notation. It's developed to work with JavaScript, which is a programming language widely used in web development. Please note that JavaScript, all one word is different from the other very common programming language, Java. JavaScript and Python are very closely related. Java is a different beast entirely. Anyway, so JSONs were developed so that these web design programs, JavaScript programs, could store and share data. There are some minor differences between JavaScript and Python, or the JSON file format in Python. First up, Booleans. In Python, capital T in true, capital F in false. JSON, all lowercase. All right, when we have no value, Python's going to use none with the capitalized none for that. Almost all other programming languages, including JSON and JavaScript, are going to use null instead of the word none. Quotes. Python will let you use single quotes or double quotes. JSON, only double quotes are permitted. A minor difference there, just something to keep in the back of your mind. Maybe a reason to start using double quotes as your first choice. I don't know. All right, commas. So Python will let us put an extra comma at the end of a list. There's a comma there following the two. This is perfectly valid in Python and makes a really excellent multiple choice exam question for quizzes, for exams, and it's also something that's really easy to just pull up Python and test during an exam. So you might put that one in the back of your mind. JSON does not permit that extra comma at the end. That'll give you an error. Keys in Python can be any type. These are integer keys. We can use anything immutable. We can't use lists, but yeah, so integers, we can use text, we can use booleans. In JSON, only strings are allowed. So if I wanted to use 3 as a key, I'm going to need to put it in quotation marks. All right, cool things to remember. All right, let's talk a little bit about reading a JSON file. So assume I have a JSON file stashed somewhere on disk. It's just a giant string saved in a file. And when I read it in, I'm going to have some parsing code. We'll talk about what this looks like on the next slide. But that's just going to turn this into a Python data structure. This one's going to get turned into a dictionary. If this had a list in it, it would get turned into a list. If it had an integer, it would be turned into an integer. But then, once I get it into Python with the parsing code, I can go up and do whatever my analysis requires. In this case, I'm just getting out some data about Cindy. She scored 12 points here. All right, let's take a look at what this parsing code looks wrong way like. All right, here we go. So we'll be importing the JSON module. And then, actually, to be honest, you guys don't need to understand this at this point. We're just going to be copying and pasting this. It's going to essentially open a file, and then it's going to load this using the JSON module and return this JSON data. Return the result of the JSON load applied to the open file, which is going to be a list or a dictionary. So all we're going to do is copy and paste this, and in fact, I'm going to do this right now. If you guys want to do it with me, let's see here. Oops, oh dear. Come on, Mike, get this right. Copy. Let's head over to Jupyter, and I'm just going to stick this right here. All right, back to PowerPoint. There we go. All right, just a little bit more about data structures and files and the connection. Why do we need both of them? Why not just have data structures? Why not just use dictionaries and lists? The problem is that they die when our program ends. We lose that data, it goes away. So if I have data structures, if I've got a list of something, I need to save it if I want to come back to it and use it again after I power down the computer. So that process is called serialization, where I turn it into a file. Now files are going to be stored on the hard drive of the computer. They're going to be available after we turn the computer off and back on again. So why not just use files? Oh, by the way, the process of reading a file and putting it into a data structure is called parsing. All right, so why not just use files? Number one answer here is speed. Reading from a file is incredibly slow. But if I had to read from the file and then go through, data structures provide all sorts of really nice features, like being able to index into them. For a dictionary, we can do key lookups. They're Python-friendly formats. Files, not so much. They're just giant strings. And so converting it into a data structure makes it possible to do things very quickly to find the information we need. One thing as you guys continue on in the homework and doing the projects If you find that when you do a kernel restart run all, if it's incredibly slow, one thing you might look for is, am I reading a file more than once? Reading a file is slow. And if it takes several minutes for your Jupyter Notebook to run, that's one thing to look for. In fact, we're going to start checking to make sure you guys only read files once, only download something from the web one time, and then make it, put it in a data structure and use it for the entire time that you guys are working. All right, next up, I just want to introduce the idea of serialization. It has nothing to do with breakfast. This is the idea that I'm going to take a data structure. It could be something complicated. In this case, I've got, this is my code example. I've got my dictionary here. I've got the mouse pointer in the wrong spot. It's a dictionary with one entry. A serialization needs to turn whatever complicated data structure this is into a string. So it's going to, by serial, we're talking about one thing after the other, one after the other, one after the other. Just something a lot like a list. In this case, it's a list of characters. So serialization code converts whatever data structure we have into a string that we can save to a file. So what does this look like? It's going the wrong way again. Gotta click the down button. All right, here it is. We're going to import JSON. This is going to be a write JSON. All right, please notice that a function like this needs two things. The first one only required the path. All I needed to do was tell it where the data was, and it gave it back to me. This one requires where do I want to save it, and what data do I want to save. So two parameters. Now we're still going to open a file, call the file f, and then we're going to use a function JSON dump. And again, you don't have to understand any of this stuff to be able to use it. To use it, we just need to know what these parameters are, path and data, and then it'll write the file. So path is a lot like file name. All right, I'm going to go ahead again and just copy and paste this over into my Jupyter Notebook so I've got it available. Copy. Here we go, Jupyter. Let's get a new cell. Put this one right here. No, that's the wrong. There we go. One other little detail I'm going to add. I'm going to do all of my importing in one spot, and I don't need to import JSON twice. So I'm going to just delete it from right here, and I'm going to move this one up to my cell where I import stuff. We'll just have imports right there. There. And now I've got my two functions, reading, got an extra line there, don't need that, and writing. All right, cool. All right, part 3 of today's lecture. Quick demo. What I'm going to do is I'm going to write some code that's going to just count the numbers in a list, but that list is going to be saved in a JSON file. So I need a couple things. I need the location of my file, and that's the path, including the file name, and it's going to output the sum. When I'm all done, I'm going to be going to the command line, the command prompt. I'm going to type Python or Python 3, running the name of my file, and giving it this as an argument. So we're going to go back, we're going to get some review of command line arguments. So first up, what I'm actually going to do is start out my development in Jupyter Notebook. You guys already have that open. It gives me a convenient place to put in some templates. You can take notes, some extra cells, and then we'll copy and paste the important pieces over to idle. So forgive me that I'm using lots of tools to do this. I hope that's not confusing. My goal is to be instructive, so hopefully you guys will learn some stuff. All right, I'm back. I added some stuff to my template file, so as you're following along, you can use these cells as a way to guide your learning. First up, when I copied all these things in, I never ran any of these cells. So I need to go ahead and do Shift-Enter to import things, Shift-Enter to define my read function, Shift-Enter again to read my data, to the write JSON, the read JSON file, and the write JSON file. Okay, now that those are available, next, here's demo 1. We're going to write a program that leads a list of numbers from JSON and outputs the sum. So first, we need a JSON file with a list of numbers. So I'm going to go back over here to this page on my Jupyter Notebook tab. Here I'm working on the template right now. At the end, I'll save it as lecture. Here's the Looney List picture. I need another file. I need a JSON file. So I'm going to add a new text file. I'm going to name this nums.a.json. All right, very good. And now all I'm going to do is put in a list of numbers. 1, 2, 3, 4. And I need to make sure that I don't put in that extra comma. I screwed this up practicing a second ago. All right, then all I'm going to do is save this. So file, save. And now if I go back over here, I can see that I've got nums.a.json right here in the right directory already. So if I go back to my template where I'm working, that's step 1. I just created that file. It's there. All right, step 2. So I'm going to click here. It's in command mode. B for below will give me a new cell. And now I can start typing code right here. All right, so the first thing I want to do is read in the data. Pretty straightforward because I already have that function. It's called read JSON. I'm going to go up and grab that right now. I'll just copy this whole line so I can see what I'm doing. All right, it's a function. I don't need the def. I just am going to be calling the function. I need to give it a path. And I believe I named my file nums.a.json. I'm going to go back and check. It's right here. nums.a.json. Yep. All right. After that, when I call this, it's going to print out the list. Now, I didn't actually store it in data. It's just a feature of Jupyter Notebook that it prints out whatever is on the last line. So these are my data. Actually, they're numbers. I'm going to be a little more specific. Numbers. All right. Let me run this cell again. And now we'll print numbers just to make sure that I did it right. I'm curious. I can't type. I just want to make sure that I'm actually getting a Python list. And indeed, when I print out the type of whatever I just read in, JSON can be dictionary, they can be list, they can be an integer. It's all good. So printing out the type just verifies for me that I'm actually getting a list object. All right. So the next thing I want to do is print out the sum. Many of you guys have probably discovered this already, but there's a cool built-in function that works with lists that's just called sum. And I can just give sum the name of a list, and if it's integers, it'll go through and just print them, add them all up. So 1 plus 2 plus 3 plus 4 is 10. Now, when I get over to idle, this is a great feature of Jupyter that it's just going to put things in the outbox for me. But I'm going to actually need to print this out when I move this to idle. Okay, that looks good. All right, I'm going to go ahead and open up idle and move all these in, because the next thing I want to do is be able to take the name of a file from the command line and then run this code. So a quick review of command line arguments is always good. So let me go ahead and get that ready to go. All right, I've got all my work for today in my directory, CS220, lecture 18. I'm going to do a shift right click because I'm on a Windows machine and just open PowerShell right here. If you're on a Mac, go ahead and use terminal. If you prefer to navigate to your PowerShell or terminal some other way, feel free. Then I'm going to open up idle and I'm going to give it the name of the code that I want to write. I'm just going to call this sum.py because that's the one that Mina used and it's already there because she's always ahead of me. We'll open this up and in a moment it should pop up. There we go. All right, let me stop, rearrange the windows, and I'll be right back. All right, so next up, all I'm going to do is just copy and paste the pieces from Jupyter that I'm going to need to make this function work. So I'll be needing import, I'll be needing the read. I don't need write, but I'm going to need it for my next demo, so I'm going to copy it right now too. And then I'm going to go ahead and have it read the numbers from the JSON file and print out the sum. So there's all my steps. I'm going to save this and just make sure that it still works. So F5 is save and run. Let's hold on one sec. Do that and that. There we go. So it's reading in the list. It's printing out the numbers right here. There's my list. It's printing out the type. There's that. And it's printing out the sum. So indeed, this is all still working. All right, I don't need these pieces for my goal. So those were just scaffolding that's helping me go through and make sure that I'm getting everything correct. All right, and the next thing I want to do though is use command line input. So if you remember about using command line input, that was found in the sys module, and it was sys.argv was the name of the variable that holds all the command line arguments. I'm just going to print this out. Print.argv, and now I'm going to run this and make sure that it's still working. But I'm going to save it first. But I'm going to be running this from the command line. So I'm going to, oops, wrong one. That's the one running Jupyter. Don't mess with that one. Okay, here we go, command line. So if I do ls, that should give me a list of everything that we have going on here. Do ls when it's big enough. We can see that right there, sum.py. So I'm going to just do python sum.py and run this. All right, first thing it does, it's printing out that sys.argv. Those are all the command line arguments. And the only thing right here is the name of the actual program. That's rarely useful. I know it's sum.py. I had to type it right there. So let's do one more test real quick. Python sum.py, and then we'll just give it some arguments. All right, so again, argument in position 1 of the list is the name of the file, not useful. And then this first one here is that string. Remember, these are always going to be strings. The second one here, my name is in position 0, 1, 2, 3. So it just creates a list, and that's what this argv is. So I'm going to head back over to idle real quick. And what I really want to do is give this the name of a file. So I'm going to say file name is going to be equal to sys. So argv of 0 would be the name of this file. That's not what I want. I don't want to read the numbers from that. What I want is instead the first argument. And now when I read something in, I want to use my file name instead of just reading in the that nums that I've hard coded. All right, let me save this. Head back over to PowerShell and test this out. So let's see here. Python sum.py, and now the name of that file, it's actually right here, nums.a.json. It should print out the list of arguments, and then it's going to go into that file, add up the numbers 1, 2, 3, 4, and get 10. All right, let's make another file and test this again, just to make sure it's not just a fluke that it just happens to work with sum.py or with nums.a. Let's make nums.b. So I'm going to head back up here to Jupyter. This is my favorite way to make files today. We'll be going ahead and making a new text file. I'm going to put in a new list. We'll give it 10, 20, that's equal to 30, so we'll 70 and give us a nice even 100. Just make sure this works. Save this as numsb.json. Hit OK, there we go, all saved up. Back to, that's the wrong one, PowerShell, that PowerShell. ls, just to verify that I now have numsb.json. 0 bytes. I wonder if I forgot to save it correctly. Let's just try this anyway. Python sum.py numsb.json. Alright, looks like we're having a good teaching moment right here. So I'm going to read this backwards. The bottommost one is the thing that actually caused the error, and it says expecting a value, line 1, column 1, character 0. So it looks like we're getting no data in the file. And I suspected that I screwed something up because it's a length 0. But that's coming from the JSON decoder, JSON init, just all the way back up. And then this was from the file sum.py in line 15. So that's the last thing I recognize. This is where the error is coming from, right there. And the error is expecting a value. And the rest of this stuff is all inside the module. Let me head back over to Jupyter and see what I screwed up. All right, file, save. That should be enough. Let's head back over here. We'll do ls and just verify that there's actually some stuff in numsb. Perfect. And then we'll go ahead and run this again and verify the sum is indeed 100. All right, this is looking good to me. Hopefully this was a useful review of command line arguments using sys.argv. All right, I'm going to move on to demo 2 now. One sec. All right, so demo 2. Here's the idea behind demo 2. We're going to be tracking scores across multiple runs of a game, and this is just going to be the scorekeeper. So the input is to this program is going to be the name of the player and the score that they're going to record. And then at the end, we'll output the running average for that person. So here's an example. We're going to call Python, give it scorekeeper or record.py, and give it 10 points to Alice. It's going to remember that there are 10 points. Now the program is ended right here. So then we're going to record, call record pi, give Alice 20 more points, and it's going to go look up what she got before, add 20 more to that record of her scores, and report the average 15. And then if we call again with Bob, give him 13 points, it'll report Bob's average. All right, so I just reviewed what I did with the previous demo 1 using Jupyter and idle. I didn't like it. I want to just stick to one tool because I felt that was confusing. All right, so let me go ahead and pull up idle and get it all lined up the way I want it to look. Okay, one sec. All right, so here's the idea. I just rearranged the windows. I didn't do anything else. I'm going to go ahead and rename my sum file because it's got those functions I want in there. Let's see, where's rename? Save as. That'll work. And instead of record, that just doesn't make a lot of sense to me. I'm going to call this scorekeeper. It'll be a Python file. There we go. Scorekeeper. If I do ls over here, should now see that I've got scorekeeper. All right, I want to keep the import, the reading, the writing, but the rest of this can go. All right, so as I go through this, in the end, what I'm going to want to have is a record of all the scores. And this is going to be a Python dictionary where the keys are the names of the players. So something like Alice here, and then associated with that is going to be the list of all the scores she's ever gotten. Just like that. And you know, if we have a second player, we'll have Bob here. Maybe he's only played the game once and did poorly. A list of his scores. All right, so that's what this is going to look like. And now as we run the program, in fact, let me make sure I haven't made a mistake yet. So we'll just print out scores. And we'll go ahead, we can just run this in idle. See that we're getting that dictionary. It's definitely printing out. Cool, that looks good to me. All right, so the next thing I want to do, and I'm going to keep this. I'm going to write one line, more or less, and then print it out. All right, so next up, we're going to need to go get the name of the player from the command line arguments. So let's grab the command line arguments, args equals sys.argv, and that's going to be, oh, here, I don't need to do it. Here's what I really want. I'm getting the name and the score. So let's do it that way. We'll get the name, and that's going to be something from that list, and score is going to be something from that list. All right. Now, argv, the very first element, 0, the 0th element was the name of this file, which is scorekeeper.py. Do not care about that. The next thing we're going to do is give it the name, so maybe Alice, and the thing after that, so position 2 is going to be the score. Oh, good Lord. Score. There we go. And now we'll go ahead and let's print both of those out too. So we'll print name. Having a horrible time with the typing today. Name and score. All right. So let's print that. Here, we'll save it. I'm going to go over here and start doing the Python version. Python score keeper.py Alice 10. Let's see what we got here. All right. So Alice 10, perfect. It's reading it correctly. And we've got the dictionary here with all my stuff in it. All right. So next up, I've got my two things that I've grabbed from the command line. And I'm going to go ahead and take the dictionary scores. Wow, that's like the 4th time in a row I've misspelled score. All right. Anyway, scores of name. And we're going to go ahead and add to that. That's a list. It's right here. It's this list right now, 10 and 20. So we're going to append to that list the new score. All right, and then we'll print out scores again. So let's just make sure this much works. Save it. Go back up. We'll add 10 more points to Alice. And now Alice has 10, 20, and ooh, it's a string. Let's go ahead and change this score into an integer. We'll save this, run it again, make sure we're getting some numbers. Perfect. Because at the end I'm going to want to take an average and print out that average score for her. The other thing, check this out. Let me run this again and again and again. It's forgetful. It's forgetting that we added 10 to Alice's score every single time. All right, let's go ahead and fix that next. So instead of having this as our dictionary, we're going to want to read in the dictionary from a file. So I'm going to go ahead and create an empty dictionary in a JSON file for us to use throughout the rest of this. Let's see, what's the best way to do that? Creating files. I'm a huge fan of Jupyter Notebook. So we'll just go ahead, we'll grab a new text file. I'm going to put an empty dictionary in here, and then we'll save this as score file.json. All right, file, saved, make sure it's all good. And then we are back over here with PowerShell and idle. All right, looking good. All right, so now instead of having this dictionary being initialized just to this stuff, what I'd really like to do is read it from the file. So that's pretty straightforward. Just read JSON. And now I need to give it the path. And the path is, gosh, I forgot what I named it already. Here we go. Let's pull this up. All the files here. It was score file. So this requires a string. JSON. There we go. Score file JSON. And now when I do this, let's go ahead and I added one line. I'm still printing out the dictionary and the name and score. I guess I don't really need that one anymore. I just want to print the scores. So we'll save that. I'm going to come back over here and now run this again. Let's see, trace back. That means I screwed something up. Key error, Alice. Oh, that's right. So check this out. What it's doing here is it's got a dictionary that looks something like this. Scores equals empty dictionary. All right. Now, there's no key here, Alice. So the moment it gets to right here and tries to look up Alice, it doesn't have any data to go with Alice. You know, if there were an Alice, it could be an int, it could be a list, it could be another dictionary, and only lists have this append function. So it needs to absolutely know that the key Alice corresponds to a list. So here's what we're going to do. We're going to check and see if Alice is in there. If name, so Alice in this case, in scores, then I want to do something. Actually, that's backwards. If she's not there, I want to do something. So if not name in scores, so that will take this. This is going to give me a Boolean. If she's not there, it'll be false. If it's true, then I want to do something. And what I want to do, scores of name in Alice, is going to be just make this an empty list. We're going to use this kind of structure all the time working with dictionaries as we want to add things. If they're not there, we need to give it something. All right, cool. I'm going to save and run this again. Save. Let's go back over here and test this out. All right, cool. So I just ran it. We gave Alice 10 points. Let's do this again. 10 points, 10 points. Oh, still forgetful. So I'm reading in something from a file, but I never actually wrote it back out. So let's go ahead and write scores. So now that I'm done with this right here, I need to write it to a file. And to do that, here's the line for write scores. This is the important part. I don't need to, it's not going to return anything, so I don't need to save it anywhere. The path is going to be that score file.json, and the data that I'm writing is scores. All right, so I've added one line. Let's save this and run it. All right, teaching moment. I screwed something up. 1 second, what did I mess up? Oh, copy paste mistake. Check this out. When I copied the line so that I could remind myself that I needed a path and data, I didn't delete the colon. All right, so save and, oh, and it even pointed it to with a little arrow right there. All right, save and run. All right, cool. And now it worked. It didn't crash. I've got a dictionary that's being printed out. It's got a key Alice and her score 10. Let's run this again and again and again. I was kind of hoping at this point that by reading it and writing it, I would be getting it to remember everything. Let me see what I did wrong. Teaching moment indeed. This is it right here. So I was talking about how scores look like this. They started out as an empty dictionary, and I left that line in there. So the moment I read in a real dictionary, I nuked it right there, and it's gone. Oh, that's embarrassing. I hope you guys are laughing at home. Enjoy it. I make mistakes all the time. All right, let's try this again. So Alice just read in. She had 10 from the last time I ran it when I wrote it down here. Perfect. That's looking good. If we run this again and again and again, it now remembers that history. It's adding scores for her. If we do this again, but let's give Bob 5 points. There we go. We now have a second entry. Let's oh, this is fun. Like 100,000 points. Indeed, things are looking good. All right, this is almost doing everything that I wanted to. I don't want to print out the dictionary. Instead, what I wanted to do was print out the average score for that player. So instead of printing the scores, we want to print the average. And then let's just make a variable called average, and we'll compute that right here. Average is equal to, let's see, we're going to use the sum. And now we can get that list of numbers from scores of name. Okay, and that scores of name is just going to be a list. We'll add them all up with sum. Okay, great. And then we're going to divide by the number of scores. So that will be length of scores of name. Hope I'm not doing too much and confusing people. So we're going to add up all the scores. This scores name is a list with, here it is right here, 10, 10, 10, 10, 10. So Alice should have 10 for her average. The length of the scores, I'm looking up that list of scores and counting how many there are. 1, 2, 3, 4, 5 for Alice. So 50 divided by 5 should be 10. We'll print that out. All right, I added 2 lines without printing anything. One of them is a print line though. I feel pretty good about that. So save this. We'll run it again. Yeah, I got 100,000. It's already in my data, so if I add another 100,000, I should get 200,000 divided by 2, gives me 100,000 for an average. So I've got 2 scores now with 100,000. If I add in, let's say, 400,000, that should be 600,000 total. Average of 3 divided by 3 is 200,000. Looks like it's working. Let's go ahead and change Alice's score. Right now she's got 50 points with 5 entries, so we'll give her 60 points. That'd be 110. How about 70? 70 points with 6 entries, 120 points total. Divided by 6 entries, she should have an average of 20. Yeah, looking good. Looking good. Bob has 5. Run this again. Let's give Bob, let's see, if we give him 15 points, he'll have 5 plus 15 is 20. 2 scores, he'll have an average of 10. Still in last place, but he tries. Tries really hard. Okay, guys, this is going to do it for me. Let me pop back over to PowerPoint and give you guys some advice about studying for this course. All right, so here's the idea. Almost all of our PowerPoint presentations have demos at the end. Demo 1 here, number count, I did that one. Demo 2, score tracker, I did this one. But there's 3 more here. This particular one is using football scores, or information about football players, forgive me. It's a dictionary of dictionaries with player IDs and a whole bunch of information about them. So the goal here is write a program that, given Python lookup, the name, like an ID number, and the name of the data we want to write out, go get the guy's name. If you want the age, then we should be able to write 2801 and give it the keyword age and look up that dude's age. All right, so that's the idea. As you're studying for this, if you can write this program on your own just as extra practice, it's extra practice. You'll learn more. All right, there's another one here, prime number caching. So you remember early in the semester, we wrote a program that computed whether a number was prime or not. And it had to go start with 1 and then work its way all the way up through whatever number we were trying to find. Now, one of the things we could do is just store all of those numbers that we found to already be prime to a file. So let's write that function that is going to, as we go through and check to see if something's prime, if it's there, we'll go ahead and write it out as a prime number and just store that in a file. That way, so input n, I might put in 100 and say how many primes are less than that number. I can go ahead and just read them from the file if they're there. And if they're not there, compute them. And then when I'm done, stash them in the file. So the next time I run it, it's a lot faster. All right, and then number 5, the uppercase autocomplete. So the goal here, ignore that, that's wrong. That didn't get updated. Okay, the idea here is that I'm going to put in a phrase or a partial phrase and then a star to complete it. And the output is going to be the uppercase version of whatever I put in, or options to auto-complete it. So just here's an example. I run my program. I called it shout because we're going to make everything uppercase. So give it a message, hi. There's no star. It's going to take hi and put it in its dictionary. Store it in a JSON file. Message hello. It's going to shout it out, but it's also going to store that same message in the data, in that data file, the JSON file. And then if I give it a message H with a star, that's going to be the clue that it's not complete. And so what it's going to do is give me all of the choices so far that it's seen that begin with these letters. In this case, just an H. And then it's going to let me select from this list. And when I choose one, it's going to print out hi, shout hi. All right. The idea is that we want this to work every single time we run it. So if it's seen a word before, we'll stick it in the dictionary. This is excellent practice. So if you guys can get through this, it should be like a real message to you that you've nailed it and that this stuff is clicking. All right, that's going to do it for me. Have a great day.